Solid rocket motors have played crucial roles in launching spacecraft like the Space Shuttle into orbit, and they are also used to power modern anti-tank weapons. In this video, I will delve into the inner workings of solid rocket motors, explaining how they function and their significance in the aerospace and military industry. A solid rocket motor is a type of rocket engine that uses a solid fuel and oxidizer. This is different from a liquid rocket engine, which uses a liquid or gaseous fuel and oxidizer. A hybrid rocket engine is a combination of these two. It uses a solid fuel while using a liquid or gaseous oxidizer. The outer casing of the motor ensures it can withstand the high pressures within the combustion chamber. Often a liner, or also called insulation, is attached to this casing to reduce the casing wall temperature and prevent the casing from melting. Next we have the propellant, which is composed of multiple grains. Each grain is a mixture of a solid fuel and oxidizer. When ignited, the propellant combusts, converting chemical energy into temperature and pressure. Finally, at the end of the motor, we have the nozzle. The nozzle accelerates the flow created by the pressure difference between the inside of the combustion chamber and the surrounding ambient pressure. It generates a force called thrust by expelling exhaust gases. This is due to Newton's third law. This law states that for every action, there is an opposite and equal reaction. So when the motor pushes the gas downward, the gas pushes the motor upward. To generate a large force, we need to expel the gas with a lot of momentum. This is why we accelerate the flow in the nozzle. Solid rocket motors offer several advantages, including simplicity and reliability due to their straightforward design and use of solid fuel, making them relatively easy to manufacture and store. Their fewer moving parts compared to other engine types contribute to their overall reliability. However, solid rocket motors have drawbacks, such as their inability to throttle. Once ignited, they cannot adjust their thrust output, limiting their versatility. Additionally, solid rocket motors generally have a lower specific impulse compared to liquid propellants. This means they are less efficient. Solid rocket motors present distinct safety challenges due to the pre-mixed combination of fuel and oxidizer, heightening the risk of combustion and explosion. Additionally, handling solid rocket motors requires careful attention to prevent accidental ignition, overheating, and structural failure, all of which can lead to catastrophic consequences. Solid rocket motors are commonly used in space launch vehicles, propelling spacecraft into orbit and beyond. They are also used in military missiles. Furthermore, solid rocket motors are embraced in the amateur rocketry communities due to their simple design. Throughout history, notable examples of solid rocket motor applications can be found, such as the solid rocket boosters employed in the Space Shuttle program, which were used for countless missions into space. Similarly, the venerable Titan II missile, equipped with powerful solid rocket motors, stood as the cornerstone of America's nuclear deterrence during the Cold War. Additionally, anti-tank missiles, such as the NLAW and Javelin, also use this type of motor. Thank you for watching. I hope you found this video informative as we explored the inner workings of solid rocket motors and their significance in the aerospace and military industries. From understanding their components to discussing their applications and safety considerations. solid rocket motors play a crucial role in propelling spacecraft, powering missiles, and enabling advancements in technology. Remember to like for more videos like this and leave a comment below if you have any questions or topics you'd like to see covered in future videos. Until next time, stay curious and stay safe.